right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is Radical Equations Part 2, and I'm already thinking, since these are going to be harder than the first set, I'll probably break this up into two videos, and we'll have a Part 2A and a Part 2B. So this will be Part 2A, and then the next one will be Part 2B. So let's go ahead and jump in. If you saw the last video, which if you didn't, I'll have a link to that, and you'll be able to see it at the end as well with the thumbnail for the entire series that I'm doing here, which is a series on Algebra 1 worksheets. The last video, I showed you that all you have to do, at least at first, is square both sides to get rid of that square root. Then we get this, because the square root and the square cancel. They're opposite operations. It would be like if I said, if I took 5 and then I times it by 2 and then divided by 2. Well, it would just be 5, because if I times something by 2 and then I divide something by 2 right afterwards, I'm always going to come back to the number I originally had, because timesing by 2 and dividing by 2 are opposite operations. So a square root and taking something to the second power are the exact opposites of each other, just like timesing and dividing, just like adding and subtracting. So now we have this. So the difference already between this one, this worksheet, and last worksheet was that in the last worksheet, we didn't really have anything squared. It was just a regular equation to solve. We can't solve this like a regular equation because there's more than one kind of letter. If there was only an n, we could solve it. If there was only an n squared, we could solve it without having to factor as well. But there's both, and you can't combine them. So what we do is we have to factor. And before we factor, we get everything equal to 0. So I'm going to add in to both sides. I know it's a little bit more work to add in, and also I want to subtract 110 from both sides. Now you might be like, oh, well, why didn't you just, subtract n squared on both sides? Wouldn't that be faster? Because, then that would only be one thing that you'd have to, do the opposite of to kind of move it over. And yeah, but then that would make the n squared negative because it'd have to subtract it on both sides. And then it'd have to multiply everything by a negative. So it'd still be 2 steps either way. So, yeah, you could subtract n squared from both sides if you were thinking of doing that. That is totally fine. Takes just as much time as what I'm doing here. So now there's nothing left on the left-hand side because I did the opposite of minus n and the opposite of 110. All right, so I have n squared plus n minus 110. Now I want to factor it. So if I want to factor it, I need 2 things that multiply to 110. And those same 2 things have to add or subtract, in this case subtract, to the middle number. Well, where's the middle number? If you don't see one, if you don't see a number and you're looking for one, most of the time it's a 1. Sometimes it's a 0. Sometimes it's a 2. It's like a hidden 2. But most of the time, if there's a number that's hidden, if you're trying to figure out, oh, well, this doesn't have a number, it's probably 1. So if you had to guess 1, because that's the most likely thing. But it's 1 because 1 times anything is that number. So 1n is the same as n. So I need 2 things to multiply to 110. Well, the first things that pop up in my head are 10 and 11. One of them needs to be negative in order to multiply to negative 110. And you could do either one. But if I make the negative 10, if I make the 10 negative and the 11 positive, negative 10 plus 11 is positive 1. So that's the combination that fits. No other combination will fit. That never happens. There's never like 2 answers to this. There's only going to be one thing that fits, if it fits at all, because sometimes it might not. Sometimes it's not factorable. This one is factorable. 10 and 11, negative 10, positive 11, because it multiplies to negative 110, and it adds or subtracts, depending on how you look at it, to 1. So I'm basically done at this point. I'm going to put some ends in front. I leave space on purpose. That way I can just kind of turn it into the fraction or the parentheses stuff right away. It saves space. And we're definitely going to need a lot of space on this. So I'm already bleeding into number 3 here. And this is just number 1. So, and the other thing too is, oh, there we go. I was wondering why I was doing that. Okay. So that's equal to 0. And now there's this fancy math term that you might have heard of in a book somewhere, or maybe your teacher told you this, called the zero product property, which basically means that if two things are multiplied and the result is supposed to be 0, then either one of them or both of them would have to be 0. You cannot multiply two numbers that are both not 0 and get 0. It's impossible. Not without some fancy footwork, maybe. I don't know. It's like an infinite limit or something. But it's not possible. Try to do it, right? I challenge you. Try to think of two numbers. Neither one of them is 0. Now multiply, and do you get 0? Pause if you want to. And the answer is no. The only way you can get 0 by multiplying two numbers is if at least one of them is 0. So that means either n minus 10 is 0 or n plus 11 is 0. One of those two things in parentheses must be 0. And they could both be 0. So since they can both be 0, then that means that we take both of them and set them equal to 0 and solve. Now, if you only have whatever the letter is, in this case n, and then like plus or minus a number, after a while you'll start to notice a pattern that always happens. The answer always ends up being the opposite of the number. Now, that only is true if there's no coefficient of n, if there's no number being multiplied by n in the parentheses. Because if there is, then that would mess things up a little bit. But basically, as long as they're pretty simple factors, you don't have to worry about it. You just take the opposite of the number. So 10 and negative 11. So because we have an I was going to say exponential, but it's radical. Because we have a radical, because we have a square root, we want to check to make sure we don't get a negative. Or that the solution even just makes sense. So I'm definitely running out of space. If I use any more space, I'm going to bleed into like number 5, right? So we're not going to use any more space than I already have. So what we'll do is I'm just going to kind of plug it in my head and check it and see if you can follow me. Under the radical, you have 110 minus n. If we say n is 10, right, so we're going to check the 10 solution, make sure the 10 solution works. 110 minus 10 is 100. Okay. The square root of 100 is 10, which equals n, which is 10. So that works. Okay, 10 works. What about negative 11? Okay. 110, right, under the radical again. Starting out under the radical, PEMDAS, start inside the parentheses, inside the grouping. 110 minus negative 11. Minus a negative 11 means I'm adding. Two negatives make a positive. Two negatives that are right next to each other, like that, make a positive. So it would actually be 110 plus 11, which is 121. The square root of 121 is 11, which is supposed to be equal to n, which is negative 11. So be really careful there, because it seems like it works. Everything under the radical checks out. We don't get a negative under the radical, because if you do, you can stop there. As soon as you get a negative under a radical, you're done. You can't have a negative radical. Right? But so even though the radical worked, I was able to take the square root of 121. It's supposed to be equal to negative 11, and it's not. It turned out to be positive 11 once we took the radical. So negative 11 is what they're calling an extraneous solution, right? Extraneous, the prefix there is extra. What does extra mean? Right? It's something you don't really need. It's something, on top of what you need. And that's what negative 11 is. It's something on top of what we need. We got two things. We didn't need the negative 11. 10 is the thing we needed. Negative 11 is extra. We don't do extra stuff in math, right? So that's where that word extraneous comes from. It's just extra. It's an extra solution that we get rid of. We just toss it. We don't need extras. Okay. Whew. And that was number 1. And you wonder why I was like, at the beginning, I was like, hey, I'm probably only going to do half of this. It would take a long time to get through this entire worksheet. So we're only going to get through half of it today. Let's do the same thing for number 2. But if you haven't seen me talk about these videos before, a lot of times I'll mention, most of the time I would say, at least in the last 20 or so that I've done, I'll mention that throughout this worksheet, I'm going to start going faster with each problem. I'm going to explain each problem a little less. So that's to your benefit, and hopefully that's good news, because maybe you don't want me to take, 5 hours to do each problem, right? And also so that I can demonstrate what it looks like and what it should look like as you start getting better yourself at this. So with that in mind, let's go ahead and look at number 2. Square square, p squared equals 2 minus p. Now we're going to subtract the 2 and add the p. So this part is going to be a little faster. I'm not going to show the in-between step. I'm going to just move everything over to the left-hand side. And when I say move, I don't mean literally. I mean like algebraically. Don't actually just move the 2 over. When you quote-unquote move, when I say move, I'm going to do the opposite. So the opposite of 2 is now going to be on the left-hand side, because I would have to subtract 2 on both sides. So I'd have to add p to both sides and subtract 2 to both sides. Okay, so that part I skipped, because again, space, right? Okay, so now we need 2 things that multiply to negative 2. And I'm going to try to squeeze it in right above 4, and then come over here off to the side to do the rest. Well, 2 only has a few factors. It doesn't have nearly as many factors as 110, although 110 doesn't have that many. But it has more than 2. 2 is just 1 and 2. 1 and 2. Now, one of them has to be negative. If you ever guess wrong, or if you're not sure which one to make a negative and which one to make a positive, if you ever get stuck on that, there's no need to get stuck, as long as you're using a pencil. Or like me, if you're using a stylus and you can erase it. Because if you get stuck there, if you're not sure, oh, well, how do I know which one to make negative? Well, just make one of them negative and make the other one positive. And then check it to make sure it works. Right? So don't let that part, trip you up. Just do it, right? Do it, and then, alter course if you need to from there. That's just good life advice. Negative 1 plus 2 is positive 1. That's what the middle number is, so that's what we want. Boom, boom. Equal to 0. So then p minus 1 equals 0, or p plus 2 equals 0. I would add 1 to both sides, and I'm not going to show that step, and I would subtract 2 to both sides. So those are my 2 answers. And I like to box both right off the bat, just because, it's like, oh, hey, I'm done. Like, that shows me that I'm more or less done. Your teacher could be a little picky about that because sometimes they want you to box the final answer, and one of these might be extraneous. One of them might not be a real answer that we're keeping. So if you think your teacher might care, just run that by them and see what they think. But let's go ahead and plug these in. So 2 minus 1 is 1, square root of 1 is 1. Okay, this works. Negative 2. All right, so 2 minus negative 2 is positive 4, square root of 4 is 2. But then that's supposed to be equal to negative 2, so that does not work. That's extraneous. Right? And actually, since I have the space for it, let me show you what I mean. Since I didn't get a chance to show you the because of space reasons on number 1. So what I just did for the number 2 is I plugged it in, right? So negative 2 is equal to 2 minus negative 2. And when you have a negative right next to another negative, it makes a positive, so that's 2 plus 2, which is 4. And the square root of 2 is not negative 2, it's positive 2. Negative 2 is not equal to positive 2. Owing somebody $2 is not the same as having $2 in your wallet. Right? Not that big of a difference. But, what about 100 and negative 100? What about, a million and negative a million? So, very different numbers. Right? So that's what that work looks like. Okay? And your teacher might want you to show that work as well. So, find out, and if they want you to show that work also, then, make sure you do. And if that's true, I highly recommend not doing this worksheet on the worksheet. I would highly recommend having another piece of paper. I'm just, doing it this way because, that's, I'm a little bit more limited. I guess I could, copy and paste this onto like a whiteboard or something, and then blow it way up, and do it like that. But why? But yeah, I would probably recommend doing that on paper. Let's go ahead and move on to number 3. Square, square, and let's kind of delineate where that ends at. And for number 3, I'm going to jump ahead just a little bit, just because I don't really have the space. So I'm going to do this one just a little bit faster, but bear with me. I'll maybe backtrack a little bit again on number 4, or maybe not, because 4 actually doesn't look that bad. But before we get to 4, let's do 3. 30 minus x squared it and the square cancel equals x squared. Then we would move everything over. So 0 x squared plus x, which is a 1x, right? Minus 30. 30 is 5 times 6. I want a negative 5 and a positive 6. That gives me a positive 1. So the answers are going to be positive 5 and negative 6. X equals positive 5, the opposite of negative 5, and negative 6. Okay? So I'm going to doing this a little bit differently because I mentioned earlier that, if you have to box only the final answer that's not extraneous, then this might be a way you could do that. Right? So again, the parentheses thing, right? You take the opposite of what's in parentheses as long as there isn't a coefficient in front of x. So 5 and negative 6 are our possible answers, and I'm going to plug these back in my head again here. 30 minus 5 is 25, square root of 25 is 5. That checks out. Right, negative 6. 30 minus negative 6 is 36. Square root of 36 is 6. But then that's supposed to be equal to negative 6, so it doesn't work. Now, if you have been paying attention, you might be thinking now, hold on. Why wouldn't we just, isn't it always just the positive answer that's the answer? And you are mostly right. If you've noticed that pattern so far on 1, 2, and 3, only the positive answer ends up being the final answer. And that is a pretty normal thing. So it's not just coincidence that 1, 2, and 3 all had the positives as their answers, but it's not necessarily true. And we'll come across some counterexamples of that later. But basically, like for number 3, if it was instead of 30 minus x, if it was x minus 30, then it might be the other way around. It might be the negative that's the answer, or something like that. So it just depends. It just depends. The more complicated um, the radical equation is, the more likely you'll potentially have something weird like a x equals a negative is a totally fine answer, because that is potentially okay. Um, it just can't be negative under the radical, and when you plug it back in, it has to equal itself. So, all right, moving on to number 4, and the last one that I'll do in the color blue. So we'll take square. It's going to cancel that. So then we have x squared is equal to 8x. Okie dokie. We still have two different kinds of x's, so we still want to factor. The factoring is going to be a little bit easier, a little bit less work, but we still have to factor because we have two different kinds of x's. So x squared, we're going to move the 8x over. And this time I don't need to try to do a standard trinomial type of factoring. This time I have two things. And really, the thing you always do first when you're factoring anything is look for a GCF. We haven't had any GCFs yet, and sometimes you just kind of can see it. But you do always look for one, because if you can take out a GCF, it makes the resulting thing a lot easier to factor if you need to keep going after that. But on here, that's all we can do. We have a binomial. You cannot do what the type of factoring that we just did on 1, 2, and 3 on a binomial. It doesn't work. There's a way to get around that, but basically it doesn't work. All right, so binomial, only thing that might be possible would be a difference of squares, but we don't have a difference of squares. And besides, you would always do GCF first. These two things have one thing in common. They both have at least one power of x. So if I divide x squared by x, I get x. When you factor, you divide. Factoring is dividing. It's like fancy dividing. Just like foiling is fancy multiplying. So if I take out an x, I'm dividing out an x. X squared divided by x is x. 8x divided by x is 8. Right? Don't forget that sign in the middle there. All right, so then x could be equal to 0, right? Because that x right there set each term equal to 0. So x could be 0 or x could be 8. Do both work? Well, if I plug in 0, 0 would be equal to the square root of 8 times 0. 8 times 0 is 0, square root of 0 is 0. Yeah, that works. 0 is fine. If I plug in 8, okay. 8 times 8 is 64. Take the square root, you get 8, and that's equal to 8. Yeah, we're good to go here. Both solutions work on that one. Okay, that was the first quad. How many more quads do we have? I'm going to use a different color for each quad. We've got 5 through 8, then 9 through 12, and then 13 and 14. So looks like we'll actually end up having just the last two will be a different color, but have a few more quads here. So let's change to green. And notice this. The first step is still to square both sides. That hasn't really changed yet. I imagine it will eventually, but for right now it's still the same, so that happens. Okay. And I haven't done anything any faster just yet. I was trying to talk and write at the same time, and I just failed at it. I was like, wait, hold on. What's going on here? We would add x to both sides. There we go. And then that's equal to 0. Okay, then we want two things to multiply to 42. That's going to be 6 and 7. That's a negative. That's a positive. Equal to 0. So it looks like 6 and negative 7. So here's one way we can do 5 a little faster. Once you get to where you're factored, if you don't have crazy factors, these are regular factors, I would say, x plus or minus a number, regular factors. Remember, it's the opposite of the number. So potentially our answers are positive 6 and negative 7. We just plug them in. All right. And plug in 6. 42 minus 6 is going to be 36. Square root of 36 is 6. Okay, that works. So 6 is good. Plug in negative 7. Looks like we're running into that same problem there. We'll plug in the negative 7, you get 49. Square root of that is 7, but then that's supposed to be equal to a negative, and that doesn't work. So 6 is our only answer. So that's one way you can do it a little faster is if you know, you can remember, oh, hey, just remember it's the opposite. Plug in the opposite of the numbers in the parentheses. Check for extraneous solutions, and then just go straight to the answer from there. All right, so for number 6, I'm not going to show the in-between step anymore, I think, at the front end. It's showing that you would square both sides. At the very beginning, I think I'm going to start skipping that step as well and just go straight into the result of what happens when you square both sides. Right, so that would be the next line, squaring both sides. Then we would move everything over, so 0 is equal to r squared. We would add r to both sides, subtract 12 from both sides. Two things that multiply to 12. And what I've done through with all of these so far is I've just kind of like, just thought of the factors right off the bat. So if you have trouble thinking of factors sometimes, one thing you could do, and I'll show you on number 6 because I have a little bit of extra space here off to the side, is if you have trouble finding the factors, like 12 has a decent amount of factors for being such a small number, just write out all the factors. Start with 1. Everything divides by 1. And then see if it's even. If it's even, it divides by 2. Okay. Does it divide by 3? Yeah, it does. It does it 4 times. And then the next number after 3, right? Look, 1, 2, 3. The next number after 3 would be 4, but I already have a 4 right here, and that's how I know I'm done with finding all the factors. Because, the next set of factors would be 4 and then 3, but I don't need to list it backwards. There's no real reason to do that. Oh, and then, some of these are going to be negative, some of these are going to be positive. Now, you could do this. You could list them backwards here. And then make all of these negative and all of these positive. So that's one thing you could do. If you get really stuck and you're just having a brain fart, you're starting to get some test anxiety, some quiz anxiety, list them all out like that. And then if one of them has to be negative, make the whole left column negative and the whole right column positive, and that would give you every possible combination, including pluses and minuses. And then from there, you could figure out which of those gives you 1. Negative 1 plus 12 is 11. Nope. Negative 2 plus 6 is 4. Nope. Negative 3 plus 4 is 1. Yes. That's the one. Okay? So, if you are ever stuck, that's what I would do. I would just list them all out and then just start adding them up until you get a set that works, that adds or subtracts to the middle number. All right, so 3 and negative 4 are our potential answers here. This looks like a pretty standard question compared to the other ones so far. So looks like 3 is probably going to work, and then negative 4 is not. So it looks like 3 is the answer. Okay. Number 7 looks a lot like number 4. So it's going to be a little bit less work. Oh, I thought said I was going to leave out the squares. Well, old habits die hard. I'll try to remember on the next one. We want to get everything to one side. Okay. And then we factor out an n. So our potential answers here are 0 and 4. And they both work. So 0 and 4. Not to be confused with the point 0, comma 4, right? This is not, these are not linear equations here, so I think that's probably fine. And then it just depends on your teacher, how picky they are, right? So here's a thought. Notice that on number 4, if we look back at number 4 real quick, the answers were 0 and 8. Number 7, the answers were 0 and 4. Do you notice any patterns? Because number 8 looks exactly the same as number 7 and number 4, except for one thing. The thing being multiplied by the letter under the square root. Right? So here's something you could do. Work smarter, not harder. If the answers in the past have been 0 and then the number that's under the square root, then as long as it's in that exact same form, those are always going to be your answers. So we can just skip right to the answer. 0 and 5. Look at that. Right? That's what it would be. And you can pause it too. If you want to go ahead and pause it and check it by solving it the way I solved it on number 7 or number 4, go ahead. And you'll see that we get the same thing. And then we could do the same thing with number 9 as well. But since we are on to a new set of 4, I'm going to go ahead and switch colors. Go to a nice gold color. I would switch to yellow, but yellow's kind of hard to see, so you got to have a little bit of twinge to it to be able to see it. So the answer to here would be 0 and 10. And that's it. Same thing for 12, actually. And 12 is in the same set of, same yellow set here, so 0 and 8. Right? Work smarter, not harder. Number 10. Speaking of things that look the same, number 10 happens to be pretty much the same as all the other ones that we've done so far. So we square both sides. I'm going to, well, I guess you don't have to, but I was going to write the m first. Not that it really matters, because I'm going to have to move it over anyways. So I add m to both sides, subtract 56. I wouldn't skip too many steps on this kind of question, just because there's a lot of sign changes, and that's like a really big way that people miss questions. And I would say really big meaning like really popular way. Like it's probably one of the most common ways to miss a problem is just to miss a sign somewhere. So 56 is 7 times 8. Well, again, we want positive 1, so negative and positive. Okay. Which means our potential answers are 7 and negative 8. Now, this part has always been the same, so I don't think we need to think about it too hard. If you plug in negative 8, it's not going to work because this is negative 8, and negative 8 cannot be equal to negative anything, cannot be equal to the result of a square root. Right? I'll say it again. A negative number cannot be equal to the result of a square root, because you can't take a square root of a negative. You can only take a square root of 0, which is 0, which is not really positive or negative. Or you can take a square root of a positive number, which would give you a positive answer. So we're done here. The answer is 7. There we go. All right. So the only one left in this set of 4 already is number 11. I feel like we're solving these faster than before somehow. All right. B squared is equal to negative 4 plus 4b. Get everything to one side. Minus 4b plus 4 is equal to 0. Want two things that multiply to 4. 1 and 4, or 2 and 2. I don't have a lot of space to write them all out like I mentioned before, so I'm just going to write the ones that work. Minus 2 and minus 2. Right? I don't think we've done one like this yet. If you haven't gotten a lot of practice factoring, this one might throw you a little bit because it's a positive number, but I can make both the factors negative because a negative times a negative is a positive. Negative 2 times negative 2 is positive 4. And then negative 2 plus negative 2, if I add up the factors, I get negative 4, the middle number. So we're good to go. B and B. Okay, so now what? There's 2 minus 2's in parentheses, which means that my answer is either 2 or 2. So since you wouldn't, be redundant and repeat the same exact number twice, we just need to see if 2 works. So if we plugged in 2 under the square root, it'd be 2 times 4 is 8. 8 minus 4 is 4. Square root of 4 is 2. And that's equal to 2, so that works. So 2 is the answer. You wouldn't list it twice. There's no point in listing it twice. So if you have a double factor like that, you know, you don't need to list it twice. All right, so we're on the last two already. Wow, it's crazy. If this has been helpful, I have lots of other videos like this on my website myersmathematics.com and on YouTube, which is probably where you're watching this, anyways. And so you can go watch the other videos. I have a whole series. This is one video in part of a series on Algebra 1 worksheets that are all found on Kuta software, which is a software that makes worksheets and some other stuff, but that's what I use them for. And of course, on my website, you can find a bunch of other free resources. If you're into free stuff and things that might help you with your math, then go check it out, myersmathematics.com. I also do tutoring, and there's whole courses in there also, or at least there will be very soon at the time of this. So go check it out. A lot of cool stuff. Just here to try to help you succeed. I don't know why I keep forgetting to square both sides, but hey, it's all good. So we square both sides. Plus 10a equal to a squared. Move everything to one side. I almost put plus. That's going to be a minus, actually. Let me erase that. So that's going to be minus 10a plus 16. There we go. So 2 and 8. And again, if you need to, write them all out. Write out every single factor until you find the one that works. But eventually, what you want to get to is, just guessing the factors that work, right? So minus a, and sometimes my a's look like 9s, but those are definitely a's. And we would check 2 and 8. So 2, let's see. 2 times 10 is 20. 20 minus 16 is 4. Square root of 4 is 2. All right, 2 works. And let's see if 8 works. 8 times 10 is 80. 80 minus 16 is 64. Square root of 64 is 8. Yeah, that works too. Okie dokie. Now we're on the last one. Square, square. R squared is equal to negative 1 minus 2r. Get everything to one side, so plus 2r plus 1. And if we factor, it would be r minus 1, or plus 1 squared. Because, you need two things that multiply to 1, 1 and 1. 1 and 1 make 2 when you add them. So we get r plus 1, which is r plus 1 squared. So r is equal to negative 1. But is it? Well, no. Even if it worked out under the radical, it doesn't matter, because we have r equals a radical. If you have a letter that's equal to a radical, you cannot have a negative answer, period. Negative answers normally don't work out too well for radicals, but you cannot have a negative answer if you have a letter equal to a square root of some stuff. That's impossible. And that's what the only example that we've seen is that kind of example. There are other examples, and we didn't actually see an example where you would turn out with a negative answer potentially. Oh wait, I'm sorry, I forgot to cross that out. I just said that was extraneous, and then I ended up boxing it anyways. So we would just say 0 with a slash through it, which means no solution, or no real numbers, something like that. Your teacher will probably already let you know how they want you to say that, but I usually just put a 0 with a slash through it, and that's good enough for me. So anyways, hope that's been helpful. If you're looking for the next set, that will be out next week. So let me scroll up to the top here. Next week, right? So as of the day of me putting this out, 6/21/22. So next week, 6/28 was when that will be out. If it's after 6/28 and you don't see it, you can always just shoot me an email. I think I have my email in the descriptions of each of the videos as well. So let me know if you don't see it, because maybe I just didn't connect it right or something. So Anyways, have a good one, and I will catch you guys on the flip side.